How does a rocket's payload mass affect mission range? Imagine trying to throw a ball across a field. The heavier the ball, the harder it is to send it far. Rockets work the same way. The more weight they carry, the more effort it takes to reach the desired destination. When a rocket launches, it needs to accelerate to a high speed to reach orbit or go to space. This process uses fuel, which is called propellant. The more payload you add, the more fuel you need to push it all the way up. This relationship is explained by the rocket equation, which shows how the change in velocity depends on the ratio of the rocket's initial mass to its final mass after burning fuel. If you increase the payload, the initial mass of the rocket grows. Because of this, the rocket has to carry more fuel to compensate. But more fuel adds even more weight, making it harder to reach the same distance or orbit. Most rockets carry only about 1 to 5% of their total mass as payload. For example, a typical satellite might weigh a few thousand pounds, but the rocket itself could weigh hundreds of thousands of pounds. If you try to put a heavier payload on the same rocket, it might not reach the same orbit or could requiring more fuel. This means the mission range, or how far the rocket can go, gets shorter with heavier payloads. To counter this, engineers design larger rockets with bigger fuel tanks and more powerful engines. But bigger rockets cost more money and take longer to build. If the payload is lighter, the rocket can carry more fuel and go farther. This is why mission planners carefully balance payload weight with fuel and rocket size. In essence, the heavier the payload, the less distance or altitude the rocket can achieve and less improvements are made. Increasing payload mass means more fuel is needed, which can limit how far the rocket can travel. This fundamental rule influences how rockets are built and how space missions are planned. It's a constant balancing act between what you want to carry and how far you want to go.